Today we are diving deep into one of the most critical components of modern day software infrastructure, which is a load balancer. In this video, we are going to specifically look at L4 load balancers, how they work, why are they important, and how crucial it is for big tech companies. Let's say if you're wondering how websites like Netflix, Google, or Amazon handle millions of requests simultaneously without crashing, the answer might be load balancing. Today, we are going to only focus on L4 load balancers and how they work, what is really going behind it. Yeah, let's get started. Before getting into this concept of load balancer, we'll just look at OSI model quickly. It's a conceptual framework and each layer serves a specific purpose. Let's say application layer, where user facing protocols like HTTP, DNS, and HTTPS are present. Presentation layer, where data encryption and compression happens. Session layer, where we manage sessions between application, establishing, maintaining, and termination of session happens in the session layer. Transport layer, this is a good old fashioned communication between computers or communication between networks happens here, TCP and UDP, where TCP is reliable communication where you and UDP is non-reliable, where the network layer handles routing and IP addressing. And data link, it manages MAC addresses and switches. And the layer one, which are physical, which are cables, electric signals, etc. So load balancers primarily operate here on the layer 4 transport layer and layer 7. These two layers are very important for load balancers. All right, so let's look at what exactly is a load balancer. Simply put, a load balancer is a device. It could be physical or virtual. So it distributes incoming network traffic into multiple servers. Why do we even need load balancer? I'll tell you. Let's say your application grows from 10 users to a million users overnight. Without using a load balancer, it would be impossible to handle that many requests because one server cannot handle that many requests. Okay, let's say you buy more servers, you do horizontal scaling, but that's not enough. How do we even manage all those servers at once? With load balancer, you can just add more what do you call add more servers to the existing infrastructure without overhauling your entire infrastructure. And another reason why we need load balancer is, let's say your one server is down due to some technical issues. You can just reroute the request to another server beside it. So these are the reasons why load balancer are actually required. Basically, there are two types of load balancers. One is the layer 4 load balancer and another is the layer 7 load balancer. So what is a layer 4 load balancer? This is the main focus of our video here. Layer 4 load balancer, as the name says, it operates at the transport layer. So we saw what is an OSI model and its different layers a few minutes back. So therefore, load balancer uses few metrics, which are IP address and ports, to make the routing decisions. And it works with both TCP, UDP, etc. Everything is fine. So what is the main difference between layer 4 and layer 7? Disregarding that it operates on different layers, the main thing is layer 4 does not peek into the request. I'll say it again. It does not peek into the request, meaning it does not know what what data is present in the request. Is it an HTTP request? Is it Is the client asking for an image? It it just it does not know the content or context behind it. It just uses few parameters such as the IP address and port to do its routing decisions. Very simple. So in layer 4 load balancer, there are two things, like two modes. One is the pass-through mode and a proxy mode. This is really interesting. Let's go through what is a pass-through mode. So pass-through mode, the definition, if you want to say, the same connection is passed through the load balancer from client to server. What does it mean? Let's say client is sending a request to the server, and here is the load balancer. The client sends the request, it just passes through the load balancer and goes to server 1. Let's say another request is fired from the client, it goes to the load balancer, it just passes through the server 2. There is only one connection made from client to server. There is no termination in between. The thing with L4 load balancer is there is no control over the selection of the servers, meaning the load balancer just uses a random algorithm to decide on which server should take the request. Algorithms to select the server. So this is basically what a pass-through mode is. Now what is a proxy mode? In proxy mode, which is dead opposite to pass-through mode, the load balancer terminates the client connection and it starts a new TCP connection to the backend. Here is a client. He sends a request to the server. First, it goes through the load balancer and terminates. The TCP connection is terminated. Now we get lot of time, or it has more control over choosing the server. Here we could use more intelligent. So this is a complete um, waveform of um, L4 load balancers. Stay tuned. We'll also look into L7 load balancer, how it works in the next video. Peace out.